2024 Wezary second term questions. I'm going to solve them. Question number 1 is the first time asked question. It is one of the question in the book. Most probably it's going to be a practice or sample problem. And every given is the same as in the book. Shazad rides on a carousel that is rotating clockwise. He travels through an arc length of 11.5 meter. If his angular displacement is 135 degrees Celsius, 135 degrees, what is the radius of the carousel? That is the question. So during angular displacement in degree, so we have to first convert this degree into radian. Degree to radian. Easiest way, divide this degree by measure of 1 radian, which is 57.3 degrees. So in this case, we will get angular displacement as 11.5, 135 divided by 57.3, answer is 2.36 radian. Then radius is the question. I'm going to the relation between angular displacement, arc length is given delta S over R, replace delta theta and R is equal to delta S over delta theta. Delta S is 11.5 meters, delta theta 2.36 radian, so 11.5 divided by answer, result is 4.9. 4.88 meters is the answer. This is the correct answer in here. Question number 2, how long does it take second hand of the clock to move through pi radian? This question is repeated 2014, 2015, 17, and 24. We know 1 second hand of a clock, so completes 1 rotation in 60 seconds. So then I will write that 1 rotation takes 60 seconds. Because given is radian, so I have to write 1 rotation in terms of radian, so which is 2 pi radian takes 60 degrees. Pi radian takes, it's so easy. If 2 pi radian takes 60 degrees, pi radian takes 30 seconds, sorry. Or you can go with cross product, you can get the same answer. And half rotation takes how many seconds? Complete rotation takes 306 seconds, 60 seconds. So half rotation takes 30 seconds. Question number 3. The time rate of change of angular speed is called angular acceleration. State definition, 2016-2024 question. Question number 4 is also from the book, only this number in the book is 11 pi. In here it's written 15 pi, which is one of the chapter question. And the tube within a revolution goes into spin cycle starting from rest. Starting from rest means initial angular speed is 0. After 6 seconds, which is delta t, its angular speed becomes 15 pi radian per second, and omega. Fine, now this is an accelerated motion, so I am going to use one of the kinematic equation. How many revolutions does each tube complete in this time interval? And delta theta is the question. I'm going to use second kinematic equation. Delta theta is equal to 1 over 2 omega initial plus omega final times delta t. So 1 over 2 omega initial is 0, omega final is 15 pi multiplied by 6. So this 6 divided by 2, 3. If 3 times 15, it's going to do 45 pi radian. But we should convert it to revolution. So angular displacement in revolution is equal to angular displacement in radian divided by 2 pi or 6.28 because answer is given pi, so I will write 2 pi. So 45 pi divided by 2 pi, pi is well simplify, 45 divided by 2, it's going to be 22.5 revolution is the answer. Question number 5. An airplane is flying in a horizontal circle at a speed of 105 meters per second, tangential speed. The pilot does not want the centripetal acceleration to exceed 7 times free fall acceleration, and centripetal acceleration is going to be AC 7 times free fall acceleration and 9 times 9.81. So let's calculate how much is this. 7 times 9.81, which is going to be 68.67 meters per second squared. Find the minimum radius of the plane. This question. This is again one of the book question, practice most probably, and the first time asked. So I'm going to use AC equation. AC is equal to VT squared over R. So R is question, replace AC and R. R is equal to VT squared over AC. VT is 105, it must be squared, divided by AC, 68.67. So let's find this, 105 squared, divided by answer, 160.5. 160.5 meters is the answer, so B is the correct answer. And question number 6. An object moves in a circle at constant speed. Which of the following is true for object? So this question, 2024 again. If an object moves in a circle, absolutely, there must be AC. AC centripetal acceleration cannot be 0, but constant speed, if it moves, AT is 0. No speeding up, no slowing down. Tangential acceleration is 0. Now, the direction of the centripetal acceleration is perpendicular direction of centripetal force. No, centripetal acceleration, centripetal force always in the same direction, so not perpendicular. In the same direction, this is incorrect. Tangential acceleration is 0. This is correct because constant speed. Direction of its velocity is constant. No, in circular motion, direction is changing. Not correct. The angle between centripetal force and tangential speed is 0. No, they're 90 degrees, so it must be 90 degrees. The answer is B. Question number 7. Identify the force that maintains circular motion of a bobsled turning around the corner. So 2015, 2024 question. So this is one of the sectional question. So it is the normal force from the curved side of the track. And question number 8. Yeah, this question is not in the book, so but the idea is studied in the book, so you can easily solve. There are two forces acting on a bar in the figure, F1 and F2. Both are equal in magnitude, 20 Newton and 20 Newton. The net torque acting on the bar is negative 12 Newton meters, so net torque is given to us. Find the distance L between the two forces. This is the question. So as you see, F1 produces clockwise rotation, so negative torque. F2 produces, according to the axis of rotation, counterclockwise rotation, so positive torque. Let's calculate them, and after that, I'm going to add them and make them equal to that torque given. So torque 2 is positive number, force F2 is 20 Newton, it's given in the question. And distance from force until axis of rotation is 3 meters. Angle is 90, sine 91, no need to write, sine 90 is 1. So result is 60 Newton meter, positive. Torque of F2, torque of F1, torque 1 is equal to, it's negative, yeah, F1 is 20 again. But this time distance is going to be counted from force until axis of rotation. It is going to be 3 plus 3 meter until F2 plus L until F1. 3 meter plus L mathematically. So when I add them, I will get result net torque as given -12. Yeah, net torque is going to be torque 1 plus torque 2. Net torque is -12. Torque 1 is so 20 times 3 plus L. Let's distribute -20 over 3 plus L. It's going to be -60 minus 20L. Then up in here, -60, -20L. Torque 2 is +60. So this +60, -60 will simplify. So -12 is equal to 20, -20L. Divide both sides by -20, -20, you will get the answer. So L is going to be 12 divided by 20, 0.6. 0.6 meter is the answer. And question number 9. How would the force needed to open a door change if you put the handle in the middle of the door? 2014 question, 2024 once again asked. So it is about required torque. Required torque stays unchanged, and F and D are inversely proportional. So if D is halt, when you take the handle in the middle, force must double. So then you will multiply them. So you'll get the same answer again, same required torque again. So if distance is halt, force is doubled. Question number 10. Identify which condition of equilibrium hold for a bicycle wheel rolling along a level height at constant speed. So first constant speed. For a rolling object, we know V and omega are related by this equation. So if one of them is constant, yes, constant speed, tangential speed, or linear speed, omega should be constant too. If speeds are constant, linear speed is constant, linear acceleration is 0. If angular speed is constant, angular acceleration is 0. If both accelerations are 0, which means complete equilibrium. And linear acceleration 0 means translational equilibrium exists. Translational equilibrium is yes. If alpha 0, rotational equilibrium is yes. So complete equilibrium. Which one? Translational, rotational, both of them. Both of them. Answer is C. A man stands on a light board of length 3 meters that is fixed onto supports at the extremities. If the distance between the point where the man stands and the first support is 0.5 meters, what is the force exerted by the second support on the board? If you know that, force exerted by the first support is 540 Newton. So it's a light board. Let's draw a light board. Yeah, this is a light board. And fixed on two supports at its extremities and ends. One of them is on the right left, the other one is on the right. Length is 3 meters, total length. Take length with the blue color. 3 meters. Okay. And there's a man stands 0.5 meters from the first support. So which one you are going to say first support? It's up to you. So let's say the one on the left is first support, one on the right, second support. So the man is going to be standing closer to first support because midpoint is 1.5. So from one first support, 0.5 meter means somewhere in here is the man. And this man is going to be applying F force, which is Fg. It's not given in the question. And this distance is given 0.5. 0.5 meter. And also, if you know that the force exerted by the first support on the board is 510, yani Fn1 is given to us. Fn1 is 540, 540 Newton. What is force exerted by the second support? Fn2 is the question. So there are two unknown questions. In this case, choose the x rotation as location of unknown force, which is not asked. Fg not asked. That's why I'm going to choose this time. Position of as Fg as axis. This is axis of rotation. Then distance from Fn1 to x rotation is 0.5. Other side must be 3 minus 0.5. Yeah, the 2.5 meters. So both forces are distance are known. Now I will use the calculation. According to Fg, which is x rotation, position of x rotation, Fn2 produce a positive torque, counterclockwise rotation. Fn1 produce a negative torque, clockwise rotation. So let's calculate them one by one. Torque of N1 is equal to, it is negative 540 times 0.5. So 540 times 0.5 is equal to negative 270 Newton meters. Torque of Fn2 is positive. Fn2 is unknown. Distance is 2.5. Angles are 90 degrees, so then that's why I don't involve the angle. Side 90 is 1. So when I add them, net torque must be equal to 0 because it's an equilibrium problem. Torque of N1 plus torque of N2 must be, some of them must be equal to 0. So 0 is equal to torque of Fn1 is 270 negative. Fn2 is 2.5 Fn2. So this is negative, other side will be positive. 2.5 Fn2 is equal to 270. Divide both sides by 2.5. Answer is going to be 108. Yes, 108 Newton is the answer. Question number 12. A cable passes over a pulley that rotates about a fixed axis. Because of the friction, the force in the cable is not the same on opposite sides of the pulley. The force on this side, on one side is 100 Newton. The force on the other side is 80 Newton. Assume that pulley is a uniform disc of a mass of 2 kilograms. And it is only determine the angular acceleration of the pulley. This is one of the chapter questions. It's the first time asked. It's a pulley, which is a disc. So center, one force, one side is going to be 80 Newton, other force, other side is going to be 100 Newton. So this cable passes over the pulley. So this force will be acting on this disc perpendicular to the radius, perpendicular to the axis of the distance. So each of them produces the torque. 80 Newton produces, say that clockwise torque, 100 Newton produces counterclockwise torque. So I will calculate the torques, and after that, I'm going to find net torque. After that, I will apply Newton's second law for rotational motion for calculating alpha. Okay. So reduces the distance for each, reduces given in the question 0.8. So this is 0.8 meter. Also here is 0.8 meter. Both distances 0.8 meter. So torque of 100 Newton is positive. Yeah, force is 100, distance is 0.8, which is good. Firing distance, yeah, 0.8 meter correct. It's going to be 80, positive 80 Newton meter. Torque of 80 Newton is negative. Torque force is 80 times distance is 0.80, which is reduced. It's going to be negative 64 Newton meter. So and calculate net torque. Net torque is going to be 80 minus 64, which is going to be 16 Newton meters. Disk more inertia is needed because we are going to use the second law. More inertia of the disk is 1 over 2 r squared. 1 over 2 m is 2 r is given as 0.8 squared. Let's calculate moment of inertia. 0.2 divided by 1 over 2 is simplified. 0.8 squared is 0.64 kilogram meter squared. Now we can apply Newton's second law for rotational motion. Net torque is 16. I is 0.64. Calculate alpha, divide both sides by 0.64. You'll get alpha. So 16 divided by 0.64, which is 25. 25 meter per radian per second square, which is going to be pardon me, 25 radian per second squared. Question number 13. Angular momentum of a disk. Yani L is given, moment inertia is given, rotational kinetic energy, kinetic energy rotational is. So to calculate more rotational kinetic energy, I can calculate first omega from angular momentum. After I use omega, I can find rotational kinetic energy. L is equal to I times omega. So L is 25, I is 5. First calculate omega, divide both sides by 5. Omega is going to be 5 radian per second. Then use the same omega for calculating rotational kinetic energy. 1 over 2 I omega squared. 1 over 2 5 times 5 squared. Result is going to be 5 squared times 5 divided by 2. Answer 62.5. 62.5 joule. Yani is dash. Question number 14. For which of the following object during rolling its translation kinetic energy is twice of the rotational kinetic energy? For a rolling object, rotational kinetic energy, if divided by translational kinetic energy, you are going to get its coefficient of inertia C. And remember, in front of every shape, if there was a coefficient, that coefficient we will calculate. Question says that rotational translational kinetic energy is twice rotational kinetic energy. And if rotational kinetic energy 1, translational kinetic energy is going to be twice of this number 2. Let's see. So which shape has a coefficient 1 over 2? Hollow sphere, it is 2 over 3. Solid sphere, 2 over 5. Solid cylinder, 1 over 2. So C is the correct answer. And question number 15. 2 kilogram bicycle tire of radius 0.33 meters start from rest, rolls down from the top of a hill that is 14.8 meters high. What is the translational speed of the tire when it reaches the bottom of the hill? So we can use the hack equation. Remember, if an object is released from rest from the top of a hill, what is translational speed at the bottom? So we know we can calculate this speed at the bottom as root of 2gh divided by c plus 1. It's a bicycle tire. Assume it's a hoop, yani c is equal to 1. Then insert all the given. So v at the bottom is going to be 2 times 9.81 times 14.8 divided by 1 plus 1 Okay, use the calculator. 2 times 9.81 times 14.8 equals divided by 2, 145. Take the root of answer, 12. It's going to be 12.05 meter per second. So this is the correct answer. And question number 16. If a mass of 600 gram attached to a vertical spring stretches spring 3 centimeters, what is the approximate value for the K? K is equal to applied force to a spring to stretch it divided by how much spring is stretched. Applied force in here is mg, gravitational force. So just m is 0.668 gram, 600 gram, or 6 kilogram times 9.81 is g divided by 0.03 centimeter is the how much it is stretched. 0.6 times 9.81 divided by 0.03 is the answer. 196.2 Newton per meter. It's going to be C. And this question is several times repeated in history. If the following equation is correct, calculate period of the simple pendulum. So it's very easy. 2 pi L over AG. 2 pi L over AG. And question number 18. If a pendulum clock is running slow means period is long period, and we should decrease the period to make it faster. So then strike period of the pendulum equation, which is the above equation, 2 pi L over G. So if you want to decrease period, length must be decreased. So make pendulum shorter, yes. Make on total increase the mass does not affect the period, amplitude does not affect the period. So it is A, and this question is asked 21, and repeat again. Question number 9 is about the waves, and the first time asked Mr. question transfers the waves shown in the figure, which are the following is correct about wavelength and amplitude. Wavelength is from one crest to another crest, and then this is lambda. This is also lambda. As you see, in 4 meter, we have 2 lambda. If 2 lambda is 4 meter, of course, lambda must be, 2 lambda is 4 meters, yeah, lambda must be lambda 4 over 2, which is 2 meters. 2 meters. And this is amplitude from equilibrium to crest, amplitude from equilibrium to trough. So this 2 meters to amplitude. To amplitude is 2 meters to amplitude is going to be 1 meter. And lambda is 2, amplitude is 1. So A is correct answer. Question number 20. A harmonic wave is traveling along a rope. The period of the wave, T, is 0.8 seconds. If the wavelength of the wave is lambda, what is the distance traveled by a given crest of the wave along a rope in a time interval 12 seconds delta T? Delta X is asked you. What is the distance traveled in a time interval is delta X? First, let's calculate the speed of the wave by using wave speed equation, which is lambda divided by period, or lambda times frequency. Lambda is 0.2, period is 0.8. So 0.2 divided by 0.8, 0.25. 0.25 meter per second. Then I'm going to use this speed equation to calculate delta X. Goes through is more with constant speed. In same medium, I can use constant speed delta X over delta T equation to calculate delta X cross product. Delta X traveled by the wave is going to be V times delta T. V is 0.25, delta T is 12, so multiplied by 12, answer is 3 meters. So C is the correct answer. This is the first time asked question, but it is a little changed one in the chapter question. The amplitude of a mechanical wave becomes 3 times of the initial value. It is a repeated question. If amplitude and energy related by this variance, square of the amplitude is energy. If amplitude 3 times increases, so when you square this, energy will be increasing 9 times. So energy increases by 9. Rhyme sends a series of pulses of amplitude, which is a down a string that's attached to a fixed boundary at the end, assuming the pulse reflected with no loss of amplitude. What is the amplitude of the point on the spin by 2 pulse crossing? So there are several pulses are going so to a fixed boundary that are coming like this. So all have 24 centimeter amplitude. Of course, after reflection, because it's a fixed boundary, it will be inverted. Now, one pulse will be moving like this, the other one will be moving like that. After that, they will meet each other. When they meet each other, crest of the first pulse and trough of the second pulse will meet, so then they will cancel each other. The result is going to be so it's a complete destructive interference. Which of the figure indicates the plane's speed is greater than speed of the sound? Yani breaking sound barrier. Breaking sound barrier. Which one? Breaking sound barrier. So shockwave forms at the edge of the airplanes. If speed of the airplane is greater than speed of sound. So this is so in here is V plane is greater than V sound. In here, V plane is equal to V sound because shockwave forms in front of the airplane. In here, less in both of them, less. Okay. Should the following sound waves travel faster? So in air, because medium is the same medium, all mechanical waves travel with the same speed. Careful, the medium is same for the waves, mechanical waves, so they travel at the same speed. Should the following statement is correct? Frequency determines the pitch, correct. Pitch of a sound decreases as frequency increases, opposite. They are direct proportional. Pitch is a measure of high or lowest sound is perceived. Correct is definition of the pitch. So both A and C are correct. Yes. First time asked question. A bat flying with a speed of 25 meters per second towards a fixed wall and it's a trip of 40 kilohertz. What is the frequency of the echo received by the bat? So bat is this is the one of the chapter question in the book. So here is the bat. Bat is approaching towards the wall and emits strip, and after that reflects from the wall this and then comes to the bat again. So in here, bat is a source. At the same time, bat is observer. So that speed, this speed is going to be source speed at the same time observer speed. Speed of the sound in here is given as. So calculate f prime. Yani f original frequency is given. F is given. F prime is going to be calculated. Now, I know f prime is equal to f v plus minus vo divided by v plus minus vs. Now source. First, let's talk about the observer. Observer bat is is approaching to the wall and also by relatively approaching the source bat. In the case of approaching, we know that pitch must rise. If pitch rises, so the denominator must get smaller. To get smaller denominator, this must be negative. Denominator must be negative. But observer, I did wrong. Sorry. I'm talking about observer. So observer, yani bat is approaching, so the pitch must rise. If it is rising, so numerator must increase. To increase that, it must be positive. Source bat is also tend to approach the observer bat. So in this case, again, it tends to approach the pitch to increase the push. This time, the source, the denominator must get smaller. To get smaller, there must be a negative. So then equation is going to be this way. F prime is equal to F times V speed of sound plus observer bat, yeah, bat in short, divided by V minus, again, source bat, yani bat. After that, insert the numbers and then find them 40 times V 345 plus 25 divided by 345 minus 25 in brackets. So let's use it. 40 is the given kilohertz, given the frequency, 40,000 by the time. This is 40,000 hertz. Converted times in bracket 345 plus 25 close the bracket divided by again bracket 345 minus 25 close the bracket. Answer is 46,250 hertz. So C is the correct answer. Yes, this is chapter question, and the first time completely asked in history. When decibel level of traffic in a street goes from 30 decibel to 6 decibel, how much greater the intensity of noise? Intensity of noise, I final over I initial. How much greater the intensity of the noise means? It's changing, of course. It's a comparison. And for this one, we made a hack in caution, maybe remember. It is very similar how we calculate I from beta. Yeah, I remember we did it like this. And log. If beta value is given beta minus 120 divided by 10, we did something like this. So if it is this question from beta, one by one you can calculate what is this is beta initial, so what is initial, this is beta final, is I final, but instead of that, this is also okay. I final, this hack and short way for this question, always correct. 10 to the power of delta beta over 10. So this is the answer. And power delta beta from 30 to 60, delta beta is going to be 60 minus 30. 30 decibel. So 30 decibel divided by 10, it's going to be 10 to the power of 3. So answer is 6, or you can calculate. I initial, I final one by one, then you can divide them. I final one, you can get the same answer. Yes, this question is repeated several times. The figure below shows the stretched string vibrating in several modes. If this length of the string is 2 meters, so which of the waves have wavelength is lambda 4 meters? So L is 2 meter, wavelength should be 4 meter. Okay. Let's check A. This is the length of the string, which is 2 meters, and I know from note to note it is lambda over 2. In the first one, lambda over 2 is equal to 2 meter cross product. Then lambda is going to be 4 meters. A is the correct answer. Yes, A is the correct answer. Well, for the other one, this is lambda over 2. This is lambda over 2. So in here, in the second one, length is equal to lambda. Length is equal to lambda. Lambda over 2 plus lambda over 2 lambda. Yani second one, lambda is going to be 2 meters. You can go this way. And then, so you is the correct answer. We found it. It is the one of the book question, chapter question, first time asked. Question number 29. Yeah, this is also sample problem in the book, and the first time asked again. A long and straight wire carries a current of 6 ampere where a part of its band into a circular loop of 1 turn and reduces 10 centimeters shown the figure that is given. Chemistry, we're asking the teacher what the figure will be given. Yeah, of course, we're going to have several configuration you can give for this question. Calculate the magnitude of the magnetic field at the center of the loop. When it says calculate the magnitude of the magnetic at the center of the loop, it's the net magnetic field resulting magnetic field. Plane of the loop and the wire coincide with the plane of the paper. So in here, both straight wire and the loop will produce the magnetic field. So then first calculate straight wire magnetic field. Straight wire, I will say straight wire's magnetic field as B1. We know the equation for straight wire, mu I divided by 2 pi t. Distance is from wire until the center is radius. And it's radius, yani mu I over 2 pi r. In fact, it's this one. For loop magnetic field, B2, I will say it is mu I over 2r. 2r. And there is one of them is mu I over 2 pi r, the other one is mu I over 2 pi. One by one, you can calculate B1 and B2. And then after that, according to right-hand rule, in here at the center, when you use the right-hand rule 1 for straight wires and thumb points up to the page, on the right of the wire, magnetic field is going to be into the page. And B1 is going to be cross into the page. But if you use right-hand rule 2 for loop, and the forefinger is going to be electric current direction, which is counterclockwise. Thumb is going to show out of the page, and B2 is going to be that. So after that, you are going to calculate them one by one, and you will find the resultant magnetic field. Let's calculate them. B1 is equal to 4 pi times 10 to the power of negative 7. I is 8 ampere divided by 2 pi is 6.28, which is a 2 pi plus pi will simplify. 2 pi times R is given as 10 centimeter 0.1. This pi will simplify and 2 and 4 will simplify 2, and after that 2 times and to the power of negative 7 times 8 divided by 0.1. Sorry, 2 times 10 to the power of negative 7 times 8 divided by 0.1 is 1.6 times 10 to the power of negative 5 Tesla. Then calculate B2. Again, 4 pi times 10 to the power of negative 7 times I is the same to R 2 times 0.1. Okay, it's going to be 4 times 3.14 times 10 to the power of negative 7 times 8 divided by, in bracket, 2 times 0.1. Answer is going to be 5 times 10 to the power of negative 5 Tesla. So then to calculate the net magnetic field, you should subtract smaller one from the greater one, and B2 is greater, B1 is smaller, so 5 times 10 to the power negative 5 minus 1.6 times 10 to the power negative 5, so minus 1.6 times 10 to the power of negative 5. It's going to be 3.43 times 10 to the power negative 5 Tesla. And of course, it's going to be in the same direction of the B2. B2 is dot, B1 is cross, result is going to be dot, and out of the page. Answer is A. It is the answer. And one by one, you can calculate them. Also, it is sometimes better if you know good at mathematics. You can subtract these two by this way. Of course, mu I over 2R is the magnetic field of loop, it's greater one, minus mu I over 2 pi R is the magnetic field of the straight wire. So you see that mu I over 2R is common in both term, 1 minus 1 over pi. Can do like this much quicker instead of doing one by one calculation. It's up to you. After that, you know what's side, you know what is it. Just one step calculation, you can find the same answer. Question 30, how can we increase the magnetic field inside a cylinder? These types of questions, you should first write the equation. Without writing the equation, you cannot answer them. Magnetic field of the cylinder, mu I n over length of the cylinder, L. So then, if you want to increase B, you should increase U, you should increase I, you should increase L, you should decrease L, or N over L must increase. By increasing number of terms, by N over L, yes, you can write this equation mu I over N over L, yes, N over L increasing, the increase is correct. By increasing the current, correct. By inserting iron rod and increasing B, correct. All of them are correct. Twice, it's a good question. Question number 24, find the direction of the magnetic force on a proton moving through a magnet as shown in the figure. So it's a proton. So you're going to use right angle tree. Magnetic field is dot, which is out of the page. Your forefinger must point out of the page. Yes. And then make your thumb pointing to the left of the page. Forefinger out of the page. Thumb is left of the page. Palm is going to show up to the page. So this is the answer for this question. And a proton is moving perpendicular to magnetic field, strength 3.5 millitesla, 3.5 times 10 to the power of negative 3 Tesla. Perpendicular, yani maximum magnetic force, magnetic force maximum QVB. Experience a downward force due to the field. If the force can calculate the kinetic energy of the proton. Kinetic energy, 1 over 2 mv squared. So we must be calculated first, and we will be calculated by using QVB equation. So that's right. Here, V is equal to F divided by QB. F divided by QB. F is given 4.5. Then 4.5 times 10 to the power of negative 21 divided by Q, charge of proton 1.6 times 10 to the power negative 19. B is given 3.5 millitesla, 3.5 times 10 to the power of negative 3. Use your calculator. 4.5 times 10 to the power of negative 21 divided by bracket 1.6 times 10 to the power of negative 19 times 3.5 times 10 to the power of negative 3, close the bracket. Answer is 8. E is equal to 8 meter per second. After that, use the equation 1 over 2. Mass is given as 1.67 times 10 to the power of negative 27 times 8 squared. 8 squared times 1.67 times 10 to the power of negative 27 divided by 2. All right, we finish. 1.67 times 10 to the power of negative 27 times 64 divided by 2. So it's 5.34 times 10 to the power negative 26 joule. So this is the correct answer. And question number 33. A proton moves in a magnetic field in a circular path. So the following question is correct to calculate the result of the circular path. When it's moving a circular path, so centripetal force mv squared over r is going to be magnetic force qvb. So if I want to calculate the radius, and this square and this we will simplify. It's going to be mv over r is equal to qb. Let's replace QB and R because I will write the equation for radius. R is going to be mv over qb. mv over qb. C is the correct answer. It's written, but C is the correct answer. And to convert the galvanometer into an ordinary ammeter that could measure high currents. So a galvanometer can become an ammeter. If you want to high current, we should connect a parallel resistor in low value, which is called shunt. So connecting resistor of very low resistance in parallel with the galvanometer is the correct answer. And this is repeated 3 times. Rapid inserting north pole of a bar magnet into a coil of the wire connects to the galvanometer, causes deflection to the right. Inserting, now here is the keywords. Inserting, first keyword. Inserting what? North pole, second keyword. Results in what? Result, deflection to the right. Result. If I want result to be opposite, one of them must change. And inserting or moving away. If you make it moving away north pole, it will be left. Or inserting south pole, it will be left. So one of them should change from first and second requirement. Okay, what must be done to the needle of the galvanometer to the left? So one of them must be changed. Inserting or north pole. If both changes, so in this case, Ralph is going to write again. Pull the north pole of the magnet out. Yeah, you pull it away and take it away. It's correct. One of them changed. Let the magnet sit at the side. There's no change in magnetic flux. You cannot use. Trust means inserting, but what? South poles is also correct. So both A and C are correct. Okay, here. So this is the correct answer. And question number 36. The unit for measuring magnetic flux, Weber. Yes, Weber is correct. Tesla times meter square also correct. It's the magnetic flux equation, which is B times A. B is Tesla, A is meter square. This is also correct. Volt times second, it's coming from Faraday's law, which is E is equal to delta phi over delta T. So delta phi is equal to E times delta T. So E is volt, delta T is second, volt times second. So all answers are correct. Question number 37. A coil of 205 turns of wire, which is N, has a total resistance 23 ohm, cross-section area 0.25 meters squared. Position is plane perpendicular to a powerful electromagnet. Yani we are going to use maximum magnetic flux equation A times B for calculating magnetic flux. What is the average current? What average current is induced in the coil during 0.25 seconds, which is delta T? That magnetic field drops from 1.6 to 0. So magnetic field is changing from 1.6 to 0. Yeah, it's going to be negative 1.6 Tesla. So to calculate electric current, first we should calculate induced EMF, negative N delta phi over delta T, and this delta phi is because of delta B. So delta B times area divided by delta T. So negative N is 205. Delta B is negative 1.6. Area is 0.25 meters squared divided by delta T is also 0.25. So they will simplify. The result is going to be 205 times 1.6 is 300, positive, because negative times negative, it's positive, 328 volt. So this is induced EMF. Then use Ohm's law for calculating electric current. Induced EMF divided by resistance. Positive 328 divided by resistance is given as 23 divided by 23. Answer is 14.26 ampere. So this is the correct choice. And which of the following is equal to Henry? So to get this, we should use the equation which includes L, coefficient of self-induction. So, which is equal to negative L delta phi over delta I over delta T. So then L is going to be negative E divided by delta I over delta T. And we know L is Henry. So is equal to E is volt divided by delta I is ampere. Ampere divided by second. So this ampere divided by second must be flipped. So it's going to be volt times second divided by ampere. Volt times second divided by ampere. So C is the correct choice. If the intensity of the electric current in a coil changes at the rate of delta I over delta T, the magnetic flux changes at the rate of delta phi over delta T, and this leads to creation of EMF, self-EMF. Then coefficient of self-induction of the coil. So coefficient of self-induction of the coil does not depend on magnetic flux change or delta I over delta T change. It only changes by specification of the coils, and for especially solenoid, we know it is equal to mu n squared A over L. So for solenoid and for any coil, it also depends on the medium, depends on number of turns, cross-section area, depends on length. So nothing else can change coefficient of self-induction. So change in increase in magnetic flux or change in magnetic flux or inducing electric current, change in electric current does not make a change in L. So this is going to be answer B. Question number 40, the maximum values of the current and potential difference in an AC circuit are 7.07 ampere and 1.41 volt respectively. So how much power is distributed in this circuit? We know power equation is equal to I times V, but if maximum values are given, we should divide it by 2. Given values are the maximum values. So electric current is 7.07. Maximum potential difference 141.4. So multiply them, divide by 2 is the answer. 707, 7.07 times 141.4 divided by 2 is answer, almost 500 watt. So B is the correct choice. Which quantity change when alternating current is generated? Frequency of alternating current is a specific number. Maximum value, maximum voltage is bound. It's a specific value. So maximum current, according to Ohm's law, it is nu divided by resistance. It is unchanged. Only instantaneous value. It can be instantaneous potential difference or instantaneous electric current. So D is change. The corresponding figure represents the angle of phase difference between the current intensity and the alternating potential difference for each of the following device. So as you see, potential difference is leading electric current by pi over 2. Potential difference leads electric current in coil, pure coil, yani pure self-inductance circuit is the answer. Question number 43, a voltage source of instantaneous value, this is V is equal to Vm sine omega t, so Vm is 20, omega is 100 pi, is connected across a series combination of pure resistor R and pure coil of self-induction 0.4, so we can calculate XL. So XL is equal to omega times L, omega is 100 pi, 100 times 3.14 times 0.2. So 314 times 314 times 0.2 answers 63, almost 63 ohms. So what is total impedance Z? Z is equal to root of R squared plus XL squared. So it's going to be R is 63 squared, R is 100 squared plus 63 squared square root. So square root of 63 plus 100 squared is, then take the root of answer, it is 118. 118.1 ohm. So the A is the correct choice. Which of the following is incorrect for series circuit in resonance? R is equal to Z. It is correct. Omega is equal to 1 over root of LC. It is correct. Omega C is equal to omega L. Incorrect. This is incorrect because omega C is equal to 1 over omega L, or omega L is equal to 1 over omega C. So this is incorrect. This is also correct. And a transformer shown in the adjacent figure, the figure is given up there, is constructed so that the coil on the left has 20 times as many turns as the coil on the right. If the input potential difference across the coil is the left, yani this is V1. Here is V1. This is V2. So what type of transformer is this? This transformer is, as you see, N1 is greater than N2. N2 is less than N1. So it is step down transformer. And for step down transformer, N2 divided by N1 is going to be less than 1. So answer is going to be, it is N2 divided by N1 step down transformer. It is marked as step up, but it is going to be step down transformer. N2 is less than N1. Because it says that, let's check it once again. The one on the left is the input potential on the left. So V1, N1, V2, N2, and step down transformer, N2 is less than N1. So answer key must be changed, must be C. And two current light waves, same amplitude, interfere. What is the amplitude resulting wave if interference is constructive? Of course, in this case, same amplitude, it will double. So twice the amplitude of the either of these waves is the correct answer. Light falls on a double slit with a slit separation, which is D, and first bright fringes sit at an angle of 16.5 degrees to the central maximum. Find lambda. So sine D sine theta is equal to m lambda. So m is the first bright. So and then lambda is equal to D sine theta over m. D is 2.02 times 10 to the power negative 6 times sine of the 16.5 is given 0.284. It's in question. Divided by m is 1. So 2.02 times 10 to the power of negative 6 times 0.284. It is 5.74 times 10 to the power negative 7 meters. But nanometer, you should multiply this 10 to the power of 9. Result is going to be, then it will change the nanometer. So it's 574 nanometers. So this is A. And which object would produce the most distinct in diffraction pattern? Which object has the smallest size? So human hair has the smallest size. It will produce the most distinct diffraction pattern. If the distance between two lines in diffraction grading 2 micrometers, slit spacing D, or micrometer to meter, multiplied by 10 to the power of negative 6. Calculate number of lines per centimeter. Number of lines per centimeter. So if I want to calculate number of person, this is better to write in terms of centimeter. So 2 times 10 to the power of negative 6 meter must be converted to centimeter by multiplying 2. So it will change the centimeter. So D is equal to 2 times 10 to the power negative 4 centimeter. Then I know that t is equal to 1 over n, number of turns, n is equal to 1 over t. So 1 over 2 times 10 to the power negative 4. So let's do it. 1 over bracket 2 times 10 to the power of negative 4, close the bracket. Answer is 5,000. 5,000 lines per centimeter is the correct choice. A laser source is the device that converts electrical energy, chemical energy, light energy, all of them. All answers are correct for this question. So this is all.